welcome to the deep dive. Today, we are plunging headfirst into the growing complexity of artificial intelligence. Not just what it can do, but really how we control it. We're opening up our stack of sources to focus on the essential guardrails needed right now for privacy, for ethics, and crucially, for intellectual property rights.
It's exactly right. Our mission in this deep dive is, well, to equip you with the knowledge to understand how organizations are trying to build AI responsibly. We've synthesized guidance for LLM developers and users on managing these, frankly, profound privacy risks. We've also got a key report on major strategic shifts in design thinking and a comprehensive analysis of the global AI copyright debate. It's just no longer enough to build the tech. We have to manage the risks across the entire AI lifecycle.
Okay, yeah, let's unpack this. We have to start with the foundational technology, right? Before we can even talk about risk, we need to get a handle on what these systems actually are and, how they get built.
Indeed. The core of today's powerful AI systems, these large language models or LLMs, relies primarily on something called the transformer architecture. This innovation, which uses these sophisticated attention mechanisms, lets the model weigh the importance of different words in a sequence. That's really what enables them to grasp context across huge amounts of text and produce language that feels, well, coherent and human-like.
And building these behemoths is typically a two-stage process. There's the initial sort of brute force training and then the refinement stage.
Precisely. Phase one is the training phase. You take massive, diverse, curated data sets, things like Common Crawl or Wikipedia, and you build the foundational model. And this is where innovation around efficiency is absolutely critical because these models are just growing so incredibly fast.
What's maybe the single biggest inefficiency everyone's talking about in that pipeline, and how are developers trying to solve it?
The main inefficiency is activation cost. When you run a massive model, traditionally you're lighting up every single parameter for every query, which is just wildly expensive. The solution our sources are really highlighting is the mixture of experts, or MOE technique.
MOE? Sounds almost like a management consultancy for AI models.
In a way, it kind of is. MOE makes models more scalable, more efficient by segmenting the network into smaller experts. So for any given input, the system only activates the few necessary experts needed for that specific task or context. It doesn't run the entire model. It's selective processing, basically. And it dramatically improves scalability, reduces latency, and cuts down costs.
Okay, that really does feel like a genuine game changer for making these models more accessible. But once the model is trained, it's powerful, sure, but often still kind of unaligned, which brings us to phase two.
Phase two, continuous improvement and alignment. This is the vital step. Is where pre-trained models get tuned to ensure their behavior aligns with ethical principles, with human instructions, general preferences, Historically, we've seen a lot of reliance on reinforcement learning with human feedback, RLHF. That's where human labelers score the AI's output to train a separate reward model.
Which sounds complex, expensive, and maybe sometimes a bit controversial, since it relies on subjective human judgment.
It is, absolutely. So newer methods like direct preference optimization or DPO are emerging. DPO aims to simplify that feedback loop. It trains the model directly on human preference comparisons like, this answer is better than that one, instead of needing to build that separate reward model first. This is all about making the AI behave properly. Not just intelligently, but safely.
Okay, here's where the conversation really shifts, I think, from building these passive models to managing active ones. The next frontier isn't just LLMs answering questions, it's agentic AI. For our listener, how does an agentic system fundamentally differ from, say, a standard chatbot?
It's the autonomy. Agentic AI systems are built on LLMs, yes, but they're designed to perform complex, goal-oriented tasks. Things like booking an entire trip, managing an investment portfolio, maybe even negotiating contracts. And with minimal human input, they don't just react to a prompt. They pursue an objective over time, dynamically adjusting their strategy as they go.
So if I ask a standard chatbot, plan me a holiday, gets me suggestions, right? Maybe some links. But I ask an agentic AI, book me a holiday to Tokyo next month within this budget. It actually goes and does it, executes the reservations.
Exactly. And that capability comes from a more advanced architecture. It needs 4 crucial components: a reasoning module to interpret the goal, a sophisticated planning module to break that goal into actionable steps, then robust memory state management, both short-term and long-term, to maintain context, maybe over days or weeks. And critically, an action module. This lets them execute tasks using external tools and APIs, things like booking flights, accessing your calendar, sending emails.
Right, the action module. The moment you start talking about connecting autonomously to, I don't know, financial APIs or checking my calendar, that level of integration, it demands a massive leap of trust, and it definitely raises major privacy red flags.
Absolutely. The autonomy and that external integration of agentic AI significantly elevates the privacy risk profile. Just has to. I mean, if an agent is managing your travel, it needs access to payment details, addresses, maybe even location data. Balancing that, profound convenience with comprehensive data protection. That requires rigorous formal risk management.
Okay, let's jump into that formal framework our sources detail. They really emphasize that risk management isn't a check-the-box exercise. It's iterative, right, throughout the entire AI lifecycle. What factors should automatically trigger a sort of high-risk assessment?
Well, risk identification is mandatory at every stage, from sourcing the data onwards. High-risk markers include things like automated outputs being used for really consequential decisions, think creditworthiness or employment. Also, the processing of inherently sensitive data health, financial info, behavioral patterns, large-scale processing that affects millions of individuals. And, importantly, processing the data of vulnerable groups, like children or patients. Low data quality is another big one, biases, inaccuracies.
That certainly makes the stakes clear. Now let's focus on the actual interaction phase. This applies whether a company uses a third-party SaaS model or develops its own LLM, right?
Yeah.
The sources identify two critical areas where things can go wrong.
Yes. The first one is input risk. This is the simple yet really persistent risk of users inadvertently feeding sensitive personal data into the prompt box. Passwords, account numbers, confidential company information, treating it like it's a private search engine when it often isn't.
But wait, if I put my name into an LLM, isn't that just part of a natural conversation? How do developers balance the need for utility personalized responses against needing strict input constraints? Is the main responsibility on the user or the provider here?
It's definitely a dual responsibility, but the mitigation responsibility lies heavily with the providers.
Yeah.
They must implement clear policies. They need to use constraints to block specific data types, deploy automated detection mechanisms that can identify and maybe mask sensitive things like social security numbers before the data is processed or stored.
Yeah.
And of course, encryption during transmission is non-negotiable.
Okay. And the second risk, that deals more with the internal workings of the model itself, the sort of black box.
That's the model processing risk. This is the deeper technical worry, the concern that the model could accidentally memorize unique sensitive data points from its vast training set and then regurgitate them later to a completely unrelated user. That's a serious data leak. Or, even more subtly, that the model could infer private or sensitive attributes about someone from seemingly harmless inputs.
Right. So we need strong technical shields against that. What are the key mitigation measures providers really need to adopt to handle that memorization and inference risk?
The primary strategy is defense in depth, basically layering security measures, network security, robust access controls, strong encryption throughout the data pipeline. But technically, we really need to focus on privacy-enhancing techniques, or PTs.
PTs, right. That's the acronym for those specialized techniques.
Yes. And the most essential PT identified in our sources is differential privacy. This involves strategically injecting calculated noise into the training data or the outputs. What this does is prevent the model from encoding individual unique data points, making it mathematically very difficult to reverse engineer information about any single person, even if someone got hold of the entire model.
Differential privacy sounds like a vital shield against memorization, definitely. But how practical is it? I mean, can a small startup building a domain-specific model realistically implement that complex level of data noise management?
Yeah, that's the challenge. Implementing PTs like differential privacy requires significant expertise and, frankly, computational resources. Smaller entities often have to rely on using smaller, more focused models instead. These inherently avoid some of the over-parameterization that leads to those deep memorization effects you see in the biggest foundation models. They essentially trade scale for a degree of safety.
And lastly on this, what about the user's right to control their data after it's been used? The whole right to be forgotten concept.
That demands clear data retention policies, first off, and mechanisms for handling data unlearning or erasure requests. However, this is, well, it's messy. True, exact unlearning, removing every single trace of impact from one data point, often requires almost completely retraining the model. That's just prohibitively expensive for most, so we often rely on approximate unlearning. This aims to reduce the impact of specific data points as much as possible without incurring that massive retraining cost. It's an imperfect solution maybe, but a necessary compromise right now.
Okay, moving from the technical to the strategic. Let's look at design. We've talked about human-centered design for decades, but the UX trend reports we looked at suggest a pretty radical philosophical shift is needed for this AI era.
Yeah, the core of this shift is moving beyond just focusing on the individual user and instead focusing on the surrounding ecosystem. The big conflict today, the sources argue, is that optimizing the experience for one user often creates an ecological or social debt that gets paid elsewhere in the system.
And that debt often shows up as raw compute power, right? Which directly translates into environmental cost.
Absolutely. The source material highlighted a pretty jaw-dropping statistic. The internet's carbon footprint already causes approximately 4% of global carbon emissions. That number is now apparently rising above the estimated impact of the entire global airline industry. So if we connect this to the bigger picture, designing systems that incentivize continuous high data, high compute usage without considering these environmental externalities, well, it's just not sustainable.
4%. Higher than aviation. Wow. That statistic alone kind of forces a reevaluation of every design choice, doesn't it? Does the source material give practical examples of what design for ecosystems actually looks like? Beyond just, feeling guilty about compute power.
It means designing for systemic resilience, essentially. You have to view the user and the product as only one actor among many, within a broader context: social, environmental, economic. This includes things like design for equality, actively checking products to make sure they don't simply embed and perpetuate existing systemic injustices, biases related to gender, age, or social standing.
So how does this redefine the role of the UX professional, especially when AI tools are increasingly automating some of the more mechanical tasks like generating wireframes or basic layouts?
The strategic role of UX becomes absolutely paramount. If AI starts handling the mechanics of design, then the human professional has to pivot to focusing intensely on the why. It shifts the role from being a tactical deliverer of assets to being a strategic leader focused on empathy, critical thinking, soft skills, and systems thinking. Their job becomes bridging that gap between powerful machine outputs and genuinely meaningful, equitable human solutions.
That is a fundamental transformation. Okay, now let's tackle arguably the most confusing global area right now: intellectual property. Who really owns the output when the machine does the bulk of the creative heavy lifting?
Yeah, the rise of AI-generated content code, art, text, you name it, has essentially shattered traditional copyright laws. These laws are historically based on human originality, human authorship, and the global legal landscape. It's fractured. There's no single standard right now.
Let's start with the U.S. position. They seem to have taken perhaps the firmest, maybe most conservative line so far.
Yes, the United States Patent and Trademark Office and the courts have been pretty clear. Works produced entirely by AI with no substantial human originality cannot receive copyright protection. This principle was kind of cemented in cases like the famous monkey selfie precedent, remember that? And reaffirmed just last year in the Deller v. Perlmutter decision. The ruling effectively states that if there isn't sufficient human sweat of the brow involved, the work falls directly into the public domain.
So if a human hasn't metaphorically broken a sweat, it's free for all.
Okay.
But if we look internationally, we see places that seem to recognize the creative complexity involved in crafting the prompt itself.
Correct. China is a great example of more flexibility. Chinese courts have actually granted copyright for AI-generated works if there was substantial human input involved in the creation process. Our sources cite an example, an image, based on something like 150 detailed prompts, with lots of adjustments and compositional choices made by the human. In that case, the court found the human prompter was the rightful author.
So if China recognizes the complex prompt as a creative act, but the U.S. standard says fully AI-generated work is public domain, are we heading toward a world where creators basically have to legally jurisdiction shop based on where they want their copyright enforced?
That's the looming question, isn't it? You have these conflicting international norms on what even constitutes authorship in the age of AI. The UK offers yet another variation. Its law attributes authorship to the person by whom the arrangements necessary for the creation of the work are undertaken. So arguably, the person setting up or directing the AI is the author, even if the model executes the command. Though importantly, the UK's protection term for that kind of work is capped at only 50 years.
This clash of definitions feeds directly into the central ownership debate we see between users and developers. Users are arguing, look, I wrote the prompt, I guided it, so it's my property.
And developers aren't exactly helping clarify things consistently across the board. You have companies like OpenAI often agreeing with the user via their terms of service, basically confirming user ownership of the output. But then you have others, like Midjourney, operating under a tiered system. They might grant full ownership to paying subscribers, but retain underlying rights for images generated by free users. This complexity feeds straight into the argument from public domain advocates who say, look, if content can be mass-produced by a machine with minimal human effort, shouldn't be free for everyone, lest it completely overwhelm and devalue original human creation.
Right. This deep dive really reveals that the challenge of AI adoption is profoundly integrated, isn't it? It's not just technical. It requires robust technical mitigations like differential privacy, yes, but also that radical shift in design focus from just the user to the entire ecosystem. And we desperately need global clarity on this fundamental question of ownership.
So what does this all really mean for you, the listener?
I think the key takeaway is that the most significant risks are interconnected and often cascading. If your training data has poor quality, if it's biased, or if it was unlawfully sourced in the first place, that leads directly to inaccurate outputs, the famous hallucinations, which, when coupled with inadequate human oversight or insufficient technical guardrails, can lead to really severe adverse consequences, especially for vulnerable populations who might rely on those automated decisions.
Okay, so here's a final provocative thought for you to mull over, building on everything we've discussed. If the biggest threat to foundational rights and privacy in these AI systems really stems from that initial step-low quality, biased, or unlawfully sourced training data, how can developers and deployers globally enforce the high standard of data curation that's required? When the underlying source material for many of these massive foundation models remains opaque or is subject to these fiercely conflicting international copyright standards we just talked about, how do we square that circle?